All right, welcome back to Pre-Calculus. So we are talking about ellipses. This is a couple of the word problems that we're going to be working on. This is number 10. So it says, okay, reflective property of the ellipse is used in lithotripsy. Okay, this is a technique for treating kidney stones without surgery. Thanks. So what they do is they pass some kind of a sound wave through your kidney here to break up the kidney stone so that you could pass it in the natural way, rather than the incredible painful way that kidney stones are usually passed. So what we're going to do here is we're going to put the person in some kind of a tub, which is going to reflect it. It says like maneuver the kidney so it's going to work. And like I would say, we're probably removing the patient so it's going to work. And then we want the focus to be where the sound waves are all going to be aimed at. Okay, so regardless of what this thing is made out of, but we want we want this to be pretty much at the focus for the kidney stone here. Okay, so we have to go back and remember. It's like, okay, how do you get to a foci? The focuses are c squared is equal to a squared minus b squared. So we have to figure out what a and b is in order to figure out what's going on here. Okay, so it looks like the major axis is 22, right? This is 22 up and down. So since this is a radius, because we're going from the center to the edge here, as a 22, we're going to take our 22 squared. I think that's 44. We'll double check. I've got a calculator right here. No, I do not. We're going to double check. Okay, I brought my calculator back, so I went through and did the 22 squared. Yes, it is 484. So we can do that. So we know what the major axis is, and that's going to be 484. And then the minor axis, this is going to be a little messy as far as the arithmetic goes here. Okay, so we're going to have x minus h squared plus y minus k squared. Major axis is in the y direction, so we're going to write down a 484 here is equal to 1. I don't know where the center is. I think we're positioning the center, so it is at 0, 0, which is always nice. Okay, and then for the minor axis, okay, we go from end to end here, okay, for 29. So that's the diameter of the minor axis. So we're going to go ahead and do 29 divided by 2. This is going to be like 14 and a half. Okay, so we're going to say 429 divided by 2. Okay, and we end up 14.5. Now, to write this in the minor axis sort of a way, we're going to need the radius of the minor axis. So we're going to have to square that. Okay, so we're going to square that. You have 210.25. Okay, so we're going to have an x over a 210.25 plus a y squared over, and it looks like we have a 484. So now I have my a squared, my b squared, okay? And we still have to figure out the focus, okay? So we're going to say, well, c squared is equal to a squared minus b squared, okay? So we're going to have 484 minus the 210.25, and that's going to be our c squared. So let's go ahead and do that. All right, so we have 484 minus, and then we have 210.25. Right, 273.75. Okay, and that's our c squared. So that's going to be the location of the foci. So let's go ahead and take the square root. So that's this one. Here we go. All right, it looks like about 16.5-ish, okay? Say, somebody's kidney at stake here, so we'll say 16.55. Got 2 decimal places here. All right, so that's from the center in the direction of the major axis. So in the y direction, we're going to go down 16.55 centimeters, as everything is in centimeters. Okay, and then it's going to be our thing. So all the way down to 22, that would be the whole diameter, 16.55 0.55. So that's what we're going to type in, see if we're going to get. So we want 16.55. I'm surprised they didn't say, oh, to 2 decimal places. Very good. Okay, good. So we'll go ahead and check. And yay, we got our little green flag, so we should be good to go. And schedule our patient for this sound therapy or this wave therapy so they could break up their kidney stone and then have an incredible amount of pain. Okay, so that looks good. And I will see you in the next video. But this is a very common word type of problem for this.